Hello! Here are some applications of the hyperbola. Now, this particular example is actually straight from your book, but the book will do it a little bit differently. And if you want to go along with the book's method, that's okay with me. Personally, I think the book's method is a little bit out there. So if you can figure that out, that's great. But here's another method for you. So let's look at this. A comet is following a hyperbolic path about the sun, and the sun is here. Actually, this answer 170 is the answer that we're looking for, but we don't know that yet, okay? So we're trying to get the 170, okay? The sun has a perihelion distance of 90 GM. So they tell you that this is our vertex here. This is our vertex, as you can see, and this is our focus point. But we know that this distance here is 90, okay? So perihelion is 90. That means the closest distance from the focus to the sun, right? So you know what we're going to do? We're going to write that fact. Perihelion is the closest place to the sun. And if you think about it, isn't this our A? Isn't this our A from the center? A, and this is our C. So how do you get that distance? Isn't it just C minus A? C is the longer distance, and A is where our perihelion is. And that's 90, which allows us to know that C is, 90 plus A. Just a little side note before we get started, okay, based on the given information. All right, let's move on. It also tells us that when the line from the comet to the sun is perpendicular, that means this guy here is straight up and down. And isn't that really our F1 or focus 1, right? And in fact, this guy is perpendicular, right, they say, and this guy is our D2, let's say, and isn't our D2, D1 somewhere over here, right? And we can actually draw that line, and that's D1, because I don't know if you guys remember this fact, but the definition of a hyperbola is that you have focus 1 distance and focus 2 distance, and when the actual difference is consistent or constant. I don't know if you guys remember that, but as with the ellipse, D1 plus D2 in an ellipse is 2A. Well, in a hyperbola, that fact is also true. So D1 minus D2, the difference of them is 2A. We kind of discussed that in class already, okay? So just a little side notes here. And this is our center, all right? So we have everything kind of set up to do, okay? Let's see what else. Okay, so you guys, don't we know we have to calculate, they tell you that distance is 281.25, and then we have to calculate ABCDE. And ABCDE follows the hyperbola standard form, okay? And we got to get it in this form. All right, so let's try this. But we already know D2. Isn't D2 281.25? That means